Hey everyone, welcome back. Ever tried to send some Ethereum and got hit with a $50 gas fee? Or waited 10 minutes for a Bitcoin transaction to confirm? These problems have plagued crypto for years, but there's a revolution happening right now. Layer 2 scaling solutions are making crypto faster, cheaper, and actually usable for everyday transactions. Today, we're breaking down how these technologies work and why they're crucial for crypto's future. If you want to understand the tech making blockchain actually scalable, hit that subscribe button and let's dive in. Number 5. The scaling problem explained. Before we talk about solutions, let's understand the problem. Major blockchains like Bitcoin and Ethereum are frustratingly slow compared to traditional payment systems. Bitcoin processes about 7 transactions per second. Ethereum handles roughly 15 to 30, while Visa processes over 24,000 transactions per second. Why are blockchains so limited? It comes down to their design. Every node in the network must process every transaction to maintain decentralization and security. This creates a bottleneck. The network can only move as fast as individual nodes can process blocks. There's also the blockchain trilemma, a concept suggesting you can only optimize for 2 of 3 properties: decentralization, security, and scalability. Bitcoin and Ethereum chose decentralization and security, sacrificing speed. The consequences are real. During peak times, Ethereum gas fees have exceeded $100 per transaction. Imagine paying $100 to send $50. It's absurd. Bitcoin transactions during busy periods can take hours to confirm. These limitations make crypto impractical for everyday use, like buying coffee or sending small payments. This is where Layer 2 solutions come in. Instead of trying to make the main blockchain faster, they build additional layers on top that handle transactions more efficiently while still leveraging the base layer security. Number 4. What are Layer 2 solutions? Layer 2 solutions are separate protocols built on top of existing blockchains, the Layer 1. They process transactions off the main chain, then periodically settle batches of transactions back to the Layer 1 for final security. Think of it like this. Layer 1 is like a courthouse that records all official transactions. It's secure but slow because every case must go through formal legal proceedings. Layer 2 is like arbitration. Parties settle most disputes quickly off-site, only going to the courthouse to register final agreements. This is faster and cheaper while maintaining the courthouse's authority. There are several types of Layer 2 solutions, each with different approaches. State channels allow participants to conduct unlimited transactions off-chain, only recording the final state on-chain. The Lightning Network for Bitcoin works this way. 2 parties open a channel, transact freely, then close the channel by recording the final balance. Sidechains are separate blockchains that run parallel to the main chain with their own consensus mechanisms. They periodically communicate with the main chain, but operate independently, offering different trade-offs between speed and security. Number 3. How rollups actually work. Let's dive deeper into rollups since they're becoming the dominant Layer 2 solution, especially for Ethereum. Understanding how they work reveals why they're so powerful. There are 2 main types: optimistic rollups and zero-knowledge rollups, or zk rollups. Optimistic rollups assume transactions are valid by default. They're optimistic about honesty. They bundle transactions, execute them off-chain, and post the results to Ethereum. If someone suspects fraud, they can challenge the transaction within a specific time frame, usually 7 days. If proven fraudulent, the transaction is reversed and the fraudster loses staked funds. Arbitrum and Optimism are the leading optimistic rollups, processing transactions at a fraction of Ethereum's cost, often 10 to 50 times cheaper. The downside is the withdrawal delay. Moving funds back to Ethereum takes about a week because of the challenge period. zk rollups take a different approach, using advanced cryptography called zero-knowledge proofs. They generate mathematical proof that transactions are valid without revealing transaction details. This proof is posted to Ethereum, which can verify it instantly without re-executing transactions. Number 2. Real-world applications and adoption. Layer 2 isn't just theoretical. It's seeing massive adoption right now, fundamentally changing how people interact with crypto. Decentralized finance platforms have migrated aggressively to Layer 2. Uniswap, the largest decentralized exchange, deployed on Arbitrum and Optimism, allowing users to swap tokens for pennies instead of dollars. Aave, a major lending protocol, operates on Polygon and other Layer 2s, making DeFi accessible to regular users, not just whales. NFT marketplaces embraced Layer 2 to avoid ridiculous gas fees. Platforms like Immutable X use zk Rollups to enable fee-free NFT minting and trading while maintaining Ethereum's security. GameFi projects almost exclusively use Layer 2 because games require thousands of microtransactions that would be impossibly expensive on Layer 1. Payment applications are finally viable. Projects like Strike use Bitcoin's Lightning Network for instant, nearly free Bitcoin payments. In countries like El Salvador, people use Lightning for everyday purchases, something impossible with on-chain Bitcoin. Number 1. The future of scaling. Layer 2 technology is evolving rapidly, and the future looks even more promising as innovations continue. Interoperability between Layer 2s is improving. Currently, moving assets between different rollups requires bridging back to Ethereum, which is slow and expensive. New technologies are enabling direct Layer 2 to Layer 2 transfers, creating a seamless multi-chain ecosystem. Layer 3 solutions are emerging. Yes, we're going even higher. These are applications built on top of Layer 2s for hyper-specialized use cases like gaming or social media that need even greater throughput. EIP 4844, also called Proto-Dank sharding, is an Ethereum upgrade making rollups even cheaper by introducing dedicated data storage. This could reduce Layer 2 costs by another 10 to 100 times, making transactions cost fractions of a penny. Bitcoin is advancing too. Lightning Network continues improving with better routing algorithms and channel management. Taproot upgrades enable more sophisticated Layer 2 constructions on Bitcoin. The endgame many envision is a multi-layered ecosystem where most activity happens on Layer 2 and Layer 3, with Layer 1 serving as a settlement layer and security foundation. Users might not even know which layer they're using. It'll just work seamlessly. Some believe Layer 2 solutions make blockchain technology finally ready for mainstream adoption, solving the scalability issues that have held crypto back for over a decade. And that's how Layer 2 is transforming crypto. From rollups to Lightning Network, these solutions are making blockchain actually usable for everyone. Thanks for watching. Smash that like button and subscribe for more crypto deep dives. Comment below, which Layer 2 solution do you think will dominate? Catch you in the next video.